Okay, so Unit 7, Lesson 1, Investigation 3, Inverse Trig Functions. Like I said earlier, we're going to try to find measure angle A, measure angle B, measure angle E, and measure angle D. Now to get started, we wrote down some trig ratios. For cosine A is 4/5, right? What are some other ratios I can use to find A, or that involve A? John?
Sin A equals 3 over 5.
Yeah, sine, right? Sine A.
Hey, at least it's still right.
It is right. Okay. And the other ones that involve A.
What?
Tangent.
Tangent, what is it, Sabrina? 3/4.
Good job.
Now, are there any others that involve A?
No.
No. Okay. Which ratios involve B? Okay, what do you got? Okay. Another one? Cosine, what is that, Josh?
3 over 5. Yeah.
And what's tangent?
3 over 4.
Ah, there we go. Remember, tangent
Reciprocal.
is opposite over adjacent. Okay, 4/3. So now, just kind of a quick side note. Are these complementary angles? Yeah, because the cosine of A is the sine of B, so they're complementary, right? And the tangents are
Reciprocal.
reciprocal, so we know they're complementary. Now, are there any other ratios that involve A or B?
Oh.
So when I knew all three sides, how many ratios could I find?
3.
3 for each angle, right? Now in this next triangle, how many sides do we know?
1 or 2.
We know 2, right? So if I want to find E, and I'm going to write one of the trig ratios with E, which one do I have to use?
Sin or sine.
Okay, here's E. What's 5? Opposite, adjacent, or hypotenuse? Opposite, right? What's 13? Hypotenuse. Which of our trig ratios involve opposite and hypotenuse?
Sine.
Sine. So in order to find E, we're going to need to use sine of E, and that equals what?
5 over 13.
5 over 13. Good. Now, is there any other ratio I can use to find E?
No.
No. If I found the third side, then I can use 2 more ratios. But we don't need to find the third side. All right. Now, how can I find D? What ratio should I use? Cosine. Why cosine, Jakai? Good. The 5 is adjacent, the 13 is the hypotenuse. So,
I didn't know I had an orthodontist appointment, so.
okay, put it back. Thank you. Thanks for letting me know. Number 6. All right, so these are the ratios we're going to use to find A, B, E, or D. Okay. Now, when we have all 3 sides, we have multiple options. When we have just 2 sides, there's only one way to find E and D. Mark, you had a question?
Whoa. No, never mind. I'm gonna point something. Just continue.
Okay. Is one of these incorrect?
No.
Okay.
I mean,
All right. So how are we gonna find those angles? How are we gonna find A? How are we gonna find angle A? How are we gonna find angle B? Can I subtract from 180? No, because I only know one angle, don't I? We just know that angle C is 90. So we can't subtract 90 from 180 to get A and B. Right? Good. We gotta use our inverse trig functions. That's what today's lesson is about, is the inverse trig functions. Okay? Now, before we get on inverse trig functions, let's remind what some inverse functions are. What's the inverse function of addition?
Subtraction.
Subtraction. To get rid of addition, we subtract, right?
Sure.
What's the inverse of multiplication?
Division.
Division, right? To get rid of multiplication, we divide. What's the inverse of something squared?
Square root.
Square root. To get rid of the square, we square root, right? What's the inverse when x is a power?
Division.
It's part of a tree. That you cut off and then you put it on fire.
Oh, reduce.
Log, right? If I have x to the power, we log. Okay? And a little math humor. Right? So, I know lots about logs. All right? So, when we're talking about inverse functions, it's the opposites of sine or cosine or tangent. the inverse function, the inverse trig functions, undo their corresponding trig functions. Now, the person who designed your calculator was very intelligent, Josh. Okay? The person who designed your calculator was very intelligent.
Yeah, I know it.
You could say he or she was. We don't know if it was a guy or girl.
It was a girl.
Now, if you look at your calculators, okay? If you look at the squared button, the second feature is square root, right?
Yes.
That's because square root is the inverse, okay? If you look at the log button, the second feature is 10 to the x, because 10 to the x is the inverse.
Yes, sir.
If you look at the sine button, or the cosine button, or the tangent button, what's the second function? Sine -1, cosine -1, tangent -1. So those are the inverses of their corresponding trig functions. Okay? So sine -1 is inverse sine. What will sine -1 get rid of? Gets rid of sine. Okay? Cosine -1 is inverse cosine. It'll get rid of cosine. And tan -1 is inverse tangent. It'll get rid of tangent. So, how can we use these? Let's try something out. If I have sine of x equals 0.5, okay? Is 0.5 the angle measure or the ratio? The ratio. Which one's the angle? X. Okay? Now, if I'm going to solve this for x, I need to use an inverse trig function. Which trig function should I use? Inverse sine, right? Because inverse sine is the opposite of sine. It's like the division to the multiplication. Okay, the addition to subtraction, it's the opposite of it. So if I want to get rid of the sine, I'm going to do the inverse sine of both sides. Okay, how do we type it in our calculator? You hit second, sine, and an inverse sine will pop up, right? So to type in our calculator, you hit second, then sine,
Second.
and it gives you sine -1, right? And it puts a parenthesis there for you. You type 0.5, then close your parenthesis. You don't have to, but it's a good habit to be into. Okay. So when we do this on our calculator, we get what? 30. And now that's an angle measure, so it's degrees. Now what happened over here?
Oh, they cancel.
They cancel. These are inverse operations of each other. So if I take the inverse sine of sine, they cancel out. We just get x.
Why would you put sine?
It's inverse sine. It's sine -1. Because I'm trying to get rid of the sine. You know, like when we have something being multiplied, we divide by that same number, right? It's the same thing. This is like the multiplication. Sine -1 is like the division. Okay, it gets rid of it. Okay. All right. Got a question, guys?
What? No.
Got a question? Okay.
Same thing, you just put me by the window and torture me.
I'm sorry. Now, when we find x, it is an angle measure. Okay? Angle measures for right triangles can only be between what numbers? If I have an angle and a right triangle. Nope. We know it's a right triangle, right? So our angles can only be, the angles A or B can only be between 0 and 90. Okay, so whenever we do inverse sine, we should get a number between 0 or 90. All right, now, that's how we can use sine. Let's say I have cosine of y equals 0.5. Right. How am I going to solve for y here?
Inverse cosine.
Inverse cosine. Okay, so we'll do the inverse cosine of both sides. Just hit second cosine in your calculator, hit 0.5, hit enter, and we get what?
60.
Gentlemen, you're off talkative over here. Okay, so y is 60 degrees. Any questions about how I use the inverse functions? Okay. Now, earlier today I said we want to find what measure angle A, B, E, and D were, right? And we made a list of all those trig functions, right? That work for A, the list that works for B, the one that works for E, and the one that works for D, right? So how are we going to use those to find the measures? Anybody know? Okay, so over here we know that cosine A is 4/5, sine A is 3/5, tan A is 3/4, right? Right? We figured these out earlier, didn't we? So how am I going to use this to find what A equals?
Inverse function, I think.
What? Okay, use the inverse function, right? Because earlier we talked about how the 0.5 was just a ratio, right? These are ratios, aren't they?
Yep.
So to find what A equals, we're going to do the inverse of that ratio, right? Now, does it matter which one I pick for A?
Not really.
No. Does it matter which one I pick for B? No. Okay, because I had all three sides. Does it matter which one I pick for E?
No, because it's wrong one.
There's only one,
Yeah,
right?
yeah.
We had to use sine for E, right?
Yeah.
And we have to use cosine for D. So let's try one of these together, right? So we haven't done inverse tangent yet, so let's start there. Right? So we know from earlier that tan of A equals 3/4. Okay, hold on a sec, guys. Okay, tan of A equals 3/4. So how am I going to find what A equals, David? How do we get rid of tangent? Inverse tangent, right? So we're going to do tan -1 on both sides, or inverse tangent on both sides. Inverse tangent of 3/4. Brandon? 36.87, and that's degrees. Now, if I did sine or cosine, what do you guys think? Will I get the same answer? Yeah. Okay, if we do sine or cosine, we'll get an answer that's very close. I know there's some rounding that has to happen. We get an answer that's very close if you use sine of A or cosine A. Right? Now, what I want you guys to do, and this will be the last thing we do today, is I want you to find B, D, and E. We already wrote the ratios down, right? So find B, D, and E using the ratios we wrote down at the beginning of class.
Wait, we have to write this down?
You don't have to write them out. You can just find the answers.
Does it matter which one you use?
For B? For B, it does not matter. Does it matter for E?
Yes.
Yeah, you must use sine for E.
And B, right?
Yep, and D, we must use cosine. Okay?
What'd you say?
Nope. You just gotta find out what B equals. You know them all if you want to. They're gonna get the same answer.
Oh man, I was saying, I come on.
Done, Matt. Work on the practice problems. If you don't the practice problems, then work on the worksheet.
When is this the fourth mark?
Yep.
Started.
Yeah, it's the first. Miss Branch and Ryan is my first.
Aaron, you retarded. This is the fourth marking.
So really you're retarded.
No, it's the fourth marking week. Guys, be nice.
Why'd you say I can't be nice on the fourth mark when I was
Did you just one guy?
No, I didn't.
I'm not.
like how we did it.
Guys.
Why?
It's not wrong, but it's also.
Would you honestly put those two next to each other?
He wasn't thinking at the time.
Honestly, I'd put them next to each other.
What?
All right, how can I find B? Which one can I use? Sine, cosine, or tangent? Any of them. Dave, how much one did you use? Sine. So we know from earlier that sine of B equals 4 over 5, right? So to solve this, we do inverse what? Inverse sine of both sides. So inverse sine of sine B equals inverse sine of 4/5. What does that equal? What is it?
Let's go, man.
Now if I add 53.13 to 36.87, what do you think it should equal? 90, right? Because remember from earlier we saw that A and B were complementary. Now to find D, which one do I have to use? Cosine. So cosine of D equals 5/13. So to find what D is, we take the inverse cosine of 5/13, and that gives us what?
67.4.
Okay, 67.4, that's fine. Okay. And to find E, we had to use sine. Matt, hold on a sec, please. Hold on a sec, please. So to find E, we do the inverse sine of 5/13. And what's the inverse sine of 5/13?
22.6.
22 point what?
62.
So 22.6. And what are 22.6 and 67.4 add to? 90, because D and E are complementary. Okay. Any questions? Okay. Now, if I have two angles in the same triangle, like A and B or D and E, when you find their angles, they should add 90 because they're complementary angles, because they're the two non-right angles of a triangle. Now, because we're doing inverse sine, will these always add exactly to 90?
No.
No, sometimes we're going to be rounding, so they might be close to 90, but not exactly 90. So like 89.999 or 90.001 or 004. Okay? All right? That's a good way you can check yourself. Are there any questions? Any questions?